Okay, we are recording. So let me introduce myself. I'm Bob Taylor, the chairman of the Electrical Engineering and Physics organization. I'm really a faculty of practice in engineering management. I spent 40 some odd years in electrical engineering and physics and project management in basically aerospace and the nuclear industry. I retired in 2010 from Lockheed Martin after several assignments at various locations like Archbold and Syracuse, New York, and Morristown, New Jersey. And pardon the dog, someone is coming to the front door. So if you heard that, we have two black labs. And they're big 90-pound black labs, and they love people. Anyway, back to business. I'm going to be sharing the slides with you. And as I said, please feel free to interrupt at any time. So we will start. We have a very strong program in engineering, electrical engineering. It's a 130 credit hour program. It's a 4-year program. It's fairly structured, and I'll show you some of the structure as we go forward. In a sense, Chris, you've seen that. Your dad probably knows about it. We haven't changed dramatically over the past few years, but we moved and changed the actual curriculum in the courses to match up with more modern technology. For example, we're heavily into programming and digital work, and that which might be a little different than what your dad went through, Chris. But generally, it's a very strong program. You don't have a lot of options in terms of courses you have to take, and we're not a super large university, so we don't offer every course every semester. So you kind of have to stick with the curriculum as we have it. Most of our engineering students go ahead and take courses in the summer to kind of catch up or pick up a general education course, but it's a fairly strong, good program. Well prepares you for industry and well prepares you for graduate school. We also have a BA in physics. We have a 4-year program. We have it's a little fewer courses. It's 123 credits. We have a BA in physics with a minor in secondary education or a major in secondary education. It's fundamentally focused on teaching, and that's 124 credits. We also have a bioengineering program. It's really a master's program, but you would enter it and get accepted into it in your junior year. Now, the bioengineering has 2 parts. It's got a section, or we call it tracks. One of them is called engineering. Fundamentally focuses on electrical and mechanical engineering as it applies to things like robotics used in medicine, or electrical engineering focus on radar techniques or that might be used in medicine, perhaps microwaves, for example, to identify and perhaps even cure breast cancer, things of that nature. You would enter the program, the what we call the 4+1 program, in your junior year. You would apply to it, and then fundamentally in your senior year, some of the course content would apply to what you have to do to get a master's, and then you would wind up 1 full year. We even recommend perhaps the summer, some summer course, but you would end up in 5 years. You would get a master's in bioengineering. It's a pretty structured program as well. Very hard, but it's a pretty good program. We're finding a lot of interest in that. All of our programs are compatible with double majors. That means a lot of extra work, and we have some various minors. Typically, the majors, many of our EE majors will minor in physics or computer engineering, mathematics, maybe computer science. I'll put a note here. The computer engineering is really specifically designing of computers, not using computers, not necessarily programming. That would be more in the computer science area. So those folks that would like to look at the entire computer from a usage application and a programming application might go to computer science as a minor. If you want to design chips, use what we call embedded software, meaning software automobiles, for example, use some embedded software. Aircraft use some embedded software. Means you don't play with it in application. You use it. But those kind of things we teach, and there's a computer engineering minor. We're looking to do a computer engineering major and really focus on both the programming and the embedded programming concepts. We also have double majors. I have three of my advisees are dual ME/EE majors. That's a lot of work. Normally, that's longer than 4 years, although I have a student right now who's on our lacrosse team. He came in well prepared from high school. He's from New Jersey as well, as a matter of fact. I don't remember where, but is definitely from New Jersey. And he came in with lots of extra courses that were college graduate or college grade courses. And he fundamentally is going to be doing an EE and an ME major in 4 years, and is basically one of the star players on the lacrosse team. He's doing a great job. It is possible. It's a lot of work, but if you have some college credits going in, it's conceivable. A lot of big companies are looking at, I say, Wilkes as a school that does have a very strong ME and EE program. We have some, so it's not something you shouldn't look at. We also have some of our EE majors majoring in physics as well, doing research in physics, as well as the applications in ME and EE rather. And we have ME and physics majors. So the fundamental issue is, if you like engineering, you like applied science, it's a good place to go. There's lots of opportunities. I offer the following chart, and you can take a look at this later when you see the recording. This, I kind of stole the concept from the U.S. government, and after many years of working with Air Force and NASA and Army, Navy, DARPA, for example, they actually talk about technology readiness, and they call them the TRLs, the technology readiness level. And so I wanted to show you kinds of where those are and what you might do after you graduate. Now, Chris, you said your dad is an electrical engineering graduate from Wilkes. What kind of things does your dad do with electrical engineering?
He works for a company called Light, and he's mainly based in software.
Uh-huh.
And he pretty much just codes.
Well, that's hard sometimes. You need help with that, Mom?
Oh, I was just nothing. I shouldn't chime in. I'm sorry.
That's all right. Not a problem. Not a problem. It's my experience, for example, was that I spent a lot of time with larger companies as opposed to smaller companies. And the only reason I show you this is, as an engineer, you can do a lot of things. You can do things anywhere from basic research all the way up into industrial production. And it's a great, engineers have a lot of fun, and that's what I looked at. That's why I spent time in engineering. I just had a lot of fun doing it. Yeah, there's some constraints. There's some constraints when you get down into some government or academics, but there are more constraints as you get into industry and production. Schedule constraints, well, in basic research, you don't have a lot of schedule constraints, but boy, you do. If you're in production, lots of schedule constraints. This gives you an idea of what we did and what you can do afterwards. Here is the fundamental look at the curriculum. Notice we have arrows on it. The arrows mean you have to take this course before you take the next course. Some of these are called co-recs, meaning you take them at the same time. For example, classically labs are co-recs with the lecture. For example, Physics 201 is the lecture, a calculus-based physics lecture. You should take Physics 204 with it at the same time. It isn't a crisis, but you do have to take at least the lecture before you get to the lab. We recommend doing them at the same time. That's what the co-requisite is. Prerequisite means you have to have the skill set from, say, a math course, and this is basically Calc 2, before you go into differential equations or before you go into some of our design work. You do need to have Calculus 2, and in some cases, differential equations. And then obviously there are some places where we have to have what we call Calc 3 or multivariate calculus before we get into the electricity and magnetism, what we call our EMAG theory courses. That granted they're in your senior year, but you need the fundamentals in math and physics. If I can take a second to talk about it, generally physics, applied physics and mathematics is called engineering, or I can say it another way, engineering, especially electrical engineering, is applied E&M theory with use of mathematics as the key tool. That said, you're going to have 4 basic calculus courses. You're going to have 3 basic physics courses, as well as your engineering courses. That's the curriculum. It's fairly well structured. Now, those who might want to say, well, what if I want to switch my major? I get into engineering. The first semester in almost all engineering curriculums is the same. Second semester is very nearly the same, with maybe a course difference. Excuse me. Generally, you could change your major from ME to EE or back and forth until you get into the third semester. It makes it a little harder. You have to make that decision before fourth semester. That's when the electrical engineers, we start digging into things like electronic design, digital design, that kind of thing. The mechanical engineers then started getting into real deep work in thermodynamics and that kind of work. But that's an interesting thought. Now, when I said you could do a double major, when you come down here and say, well, I want to do some electives, some technical electives. If you're doing both ME and EE, there are a lot of courses that are the same. So you get credit in both majors for taking those courses. What we and the mechanical engineering department do is allow you, if you're a double major and a signed up double major, you can take electrical engineering courses as tech electives for ME. You can take some ME courses as tech electives for EE. What that does is provide you a pretty strong background in design engineering. But that's our electrical engineering curriculum flowchart. It's pretty much what's on the internet, so I'm not going to go into our website. I'm not going to go into it too deeply. The one that everybody has to go through is called the general ed, what we call gen eds or general education requirements. You have to take English 101. You should take some what we call computer literacy, but we have courses that apply to the computer literacy, our computer programming and mechatronics. Clearly, we're going to teach you more than just computer science 115, which is pretty basic. In fact, I tell my advisees, don't even consider CS 115 at all. It's a kind of waste of your time, and it's the best you can do is get a credit or two for free elective. You don't have to take COM 101 because we have 2 courses, senior projects, which you're going to have to do some real serious presentations, and you're going to learn a lot about technical presentations, so you don't have to take COM 101. Don't worry about your math requirements. You're going to take more math than the average person sees. In fact, you probably have gotten more math already, even talking with your dad, than what Math 101 provides. So don't even worry about that one. You do have to take freshman foundations. That's to kind of get you from the higher into the higher education from secondary or high school education. Interesting courses. We have some that are geared for engineering students, and it's a good thing to work as a transition. You do have to take 3 courses, which I must admit were my downfall, and I got my worst grades in it. English literature, world history, and philosophy or a foreign language. The foreign language was okay, but history and literature, I sprained my brain, and I was quite happy to come out with what I would call a minimum grade of a C. I was thrilled that I passed. I had a hard time reading fiction. I was okay with science fiction, but they wanted me to read things from, well, I won't talk about it. It's just, literature was not my thing. Then there's a scientific world you got to do. Don't worry about it. You're gonna have all those courses taken care of. Basically because you're going to be taking some chemistry for engineers and physics. That's not a problem. We do want you to take, as a university, take 2 of the 5 what we call social sciences. Now, I personally recommend microeconomics. Microeconomics is kind of the economics of the workplace, as opposed to macroeconomics, which is the economics of the politician. And I understand it. I just don't think it's useful for engineers. So I recommend if you want to take an economics course, do take Economics 102, or you can take anthropology, political science, psychology, or sociology. It helps you get a little more of the left brain folks that we are into the right brain thinking process. Then you have to take an art course, what we call visual or performing arts, art, dance, music, or theater. I would have taken music. My bag was rock and roll in college, so I would have barnstormed through the music class. I could even read music. That was not a problem. I played by ear sometimes, but I could read music, and it's kind of neat. I find engineers do like music because many of them engineers are really good at mathematics and fundamentally find mathematics very easy, and so music is something that would be easy to work to. Anyway, those are our general ed courses. Your first year at Wilkes kind of looks like this. I just kind of made it a more detailed look. Have you had calculus or pre-calc, either one of you?
I'm taking honors calc right now.
Is it going to be, are you going to take any exam for it?
It's not an AP class, it's only honors, so I'm not taking an exam.
Okay, all right. That's okay. If you're taking it right now, I'd give you a quick hint at that. Aiden, are you taking any advanced classes in math? Leah, are you there? Okay.
Oh, yes. My son is taking like a pre-calculus now. He's a junior.
Okay.
So next year he'll take calculus, and he's debating whether he should take AP calculus or honors calculus, or I think it's AB versus BC. I don't know what the difference is.
I can tell you that, but go ahead. Go ahead.
And then the same thing with physics. He doesn't know if he should take honors physics versus AP physics.
That's an interesting question. Let me answer the first question. I would recommend AP math if you can do it. AB would get you through math calculus 1. BC gets you into differential equations, and some of the students who have taken BC and done very well, like a 5 score an 8 in BC, actually moved into differential equations. I had a young man and a young lady who they started off in Calc 2 and said, "Hey, we've been through this," and okay. And we talked to the math instructor, and he said, "No, let them go on." I kind of hesitate to say to say skip certain math classes. I recommend against it quite often because, in all honesty, all the math and physics courses are going to be 4 credit hour courses. If you can get A's, an easy A in a 4 credit hour course in a technical field, my recommendation is to go ahead and take it. I don't want you to waste your time, but GPAs do count when you're trying to get a job in an engineering company. I hired lots of engineers at Lockheed Martin, and I even recommend some of my engineers go interview at Lockheed. And like just one of our students recently sent me a note that he got into Raytheon down at the Mann's Space Center in Huntsville, Alabama. And his background helped him get into that, and his GPA was good, and that helped. So I don't want to bore a student with mathematics, but and science, and by having to take a lower course than you're used to. But at the same time, get easy A's when you can. All of that said, I recommend if you can take an AP course, go ahead and do it. When in math, especially. If you do it in physics, it's okay. If you take an AP physics course, you can probably skip physics 1, which is basically statics and dynamics. I kind of shy away from that one, but that's just a personal preference. Now, I hope that's a reasonable answer for you, Leah. And I think it's always get selfish as a high school student. take as high a level as reasonable, learn as much as you can. It's a good thing to do, especially in engineering. What we do, if you don't take an AP course and you take honors, what we do for all other students is give what we call a math placement exam. The math placement exam really is a way that Wilkes can put you in the right math course for yourself. It's a 40-question exam. If you get, I guess, what is it, 19 credits or 19 or above out of the 40, you probably, say between 19 and 29, you would take pre-calc. If you get 30 or above, we'd put you in Calc 1. What this says is it's not a test to try to make it hard for you. It's really an assessment to put you in the right class at Wilkes so that you could be successful. And we found that the feedback and our statistics has shown us to be pretty well geared. That test is well geared to predict where you should go. I hope that answers the question. Did it help, Leah, with what I think you should do?
Yes, I believe that it did. So you're saying that calculus AB, that would be comparable to calculus 1
Yep.
at Wilkes?
Mhm.
And then you said BC would be regarding differential equations?
Well, it actually gets you up through Calc 2, and it would cover some differential equations. So you could potentially start with differential equations, potentially. It's a discussion we would have, but I do recommend BC if you can. If you can't, that's okay. AB's fine.
Okay,
AB's fine.
okay,
All right.
thank you.
You're quite welcome. You're quite welcome. Chris, that where you're standing in honors, do it. Take it. It's going to put you in great shape to take the math placement exam. I'm guessing you would work your way into Calc 1 right away. That's not a problem. Okay, that's first year. Why do you go to Wilkes? Well, this is my unabashed sales pitch, I guess. We have a very strong program in engineering. We have 3 ABET accredited engineering courses, curricula. It's mechanical, electrical, and the environmental engineering rather. And we have, as I said, minors to match up those. Our class sizes are relatively small. We kind of consider ourselves a Wilkes family, and as an example, I'm forever getting emails from students that graduated and want to tell me what they're doing, ask for advice after, how do we pick jobs, those kind of things. So it's a family atmosphere, relatively small classes. You are going to see large classes in physics. You probably see a large class in chemistry, but then that's for lecture. You'll get down to smaller classes in what we call our discussion groups. And of course, our labs are really small, especially since most labs are going to be face-to-face, meeting with some of the COVID issues, where we pretty well stand down on eight students per lab, and you get an instructor. So it's normally the instructor that teaches the lecture and the discussion period. So it's a very, very well orchestrated lecture lab system, but fundamentally small classes. Lots of hands-on experience. Wilkes is known as a hands-on experience. You got to do your own lab work. I often get questions, and quite frankly, we had quite a challenge when we had to close down the first time last spring. We worked with some of the students, and we worked with companies, with some of the electrical engineering people. We sent them home with kits on how to do circuits, and then we had remote discussions on how to do circuits. Believe it or not, we did have some engineering fathers looking over the shoulder, even asking why we did certain things and why we use certain components. That does happen, but it's good learning experience. Our labs are taught by our discipline instructors. We do have advanced students supporting the instructors. We find that very successful. A lot of times a student will ask, a freshman or sophomore student in physics will ask an upper class person, how am I doing? Can you help me with it? They'd rather talk to the student than talk to the instructor. That's okay, but the instructor's there. We have help in class, plus we do special sessions, and we have lots of tutors. We have student tutors, and even the faculty will help out a lot. We also consider project management as one of our engineering toolkits. Engineers need to have some project discipline, especially as we go forward in today's economy. Engineers wind up running some of their own research or their own work and understanding how to plan, manage a project. Even though we're not trying to make you a detailed project manager, we give you some insight as to how it's done so that you can be a better engineer and support a program. And if you want to run a program, that you have a good basis to start from. We have a lot of connections with the local industries, including some nonprofit organizations for job experience and internships. I personally recommend, I'm going to go back a couple of charts. I recommend that in between the spring semester your junior year and the fall semester senior year, take an internship. And the reason I say to do it then is engineers will have had 3 years experience and are pretty much understand what it takes to do engineering. Interns, the companies we do business with, they like to see our students, and they would like to see the students have a good background. Also, as part of our internship program, we have some specific, what we call career planning courses that help you with your basically interviewing skills, help you with your resume. I personally help most of my advisees with resumes because I know what some of the more technically space-oriented companies want to see in a student resume. But that helps the students, and it also helps with employment afterwards. We have students calling us back after graduation, many times just say thanking them for preparing them in the internship program to work a little bit before they joined a company. I will also say this: if you do your internship between your spring junior level, your junior year, and your fall senior year, and you do a good job, many companies use that internship program as a good way to see how the students are doing. And I did it when I was at Lockheed Martin, and many companies do it now. They'll hire 2 and 3 interns with the understanding that if they do a good job, they're looking at future employees, and many students get a job offer as a result of that internship, and they don't have to reapply at the end of their senior year. All they have to do is show a diploma that they've graduated. There's a lot of companies doing that, and we have companies on our advisory board, and that's exactly what they do. In fact, I got in trouble with Lockheed Martin once because we had a student who was a semester behind, and the company liked him so well. They said, well, why can't we hire him? Does he really have to be on campus to finish up his curriculums? And I said, yes, he has to stay finishing your projects before we can give him a degree. Well, we think he's doing such a great job. We'll hire him part-time anyway. And I said, that's good. That's a good thing. But I think one thing that we as a university can do is support you finding a good employer. So I think that's, as I said, I've told some of the parents in the past, I get the question I would get is it hard for our Wilkes engineering students to be employed? And my answer is, well, not really. The question I get from a significant majority of my senior advisees is the following. They walk in my office, they show me 2 or 3 job offers and say, which one do you think I should take? And we sit and we talk it through. My answer is never take this one or that one. My answer is let's talk about what's important to you and what you like and what you did in your internship. But that's a good thing. Wilkes University students in electrical engineering, physics, and I will say mechanical engineering as well, have to make decisions. And it's not looking for a job necessarily, it's which one do you think I should take? Finally, our faculty instructors want to be here. We're a small university. We want to be here. Many of our instructors came from large universities and found that they were a bit impersonal. Not that they're bad, but they like the family atmosphere of a Wilkes type campus. Here's some of our labs, and that's a student over here. You're seeing one of our student instructors or student supporters working as the instructor is actually doing some programming in the class. And so it's we do have some of our students helping in the class, especially labs like this with computers. We have a microfabrication lab, one of the few universities that have this kind of a thing, where we actually can make a small chip. We can design and make the chips. The yellow light here you're seeing is really the light, because we have to use yellow light to protect some of the photographic processes that when we make our boards. We have what we call our physics engineering flex labs. These are fundamentally only 3 years old. They're easy to work with. You can see it right over here is a large screen. That screen, there's 4 of them in the lab, and so students can take a look at that as the instructor's going through some of the information in the laboratory. We have a very strong communications and microwave lab, and we just finished buying some more low noise investigation hardware for that particular lab. What you see here are students. The important part about it is this is students. We have full PhD instructors here. We have the students working with the instructors. It's hands-on. Lots of hands-on, the students doing the work. And I think that's a really important factor. Again, a neat part of Wilkes is you get a great education. You get to work with the equipment. You have some really neat stuff, and I didn't write it down here, but you didn't have to pay for it necessarily. You do have some courses. You have to pay courses and lab fees, and of course there's tuition. But the bottom line is it's up to we at Wilkes to go get the right equipment for you and provide that opportunity for you to use the things at Wilkes to learn. Many of the things that you see here, you're going to see them in industry. I'm going to go back a chart. I purchased many of the pieces of equipment in the lab and in the microwave lab on purpose, because that was the kind of thing that we showed when we used it in industry. So you'll get a chance to work with that same kind, not necessarily the exact same brand, but the same kind of equipment. Okay, that's it. Now, I'm just going to leave there, and let me open this with questions. I'm supposed to not take too long, but anybody have any questions?
You said earlier that we have to take a foreign language class.
You don't have to take foreign language per se. Let me go back. That's a good question. What you have to take is either philosophy or a foreign language.
Okay.
You don't have to take a foreign language. I had 3 years of French in high school. And so I at the college I went to, I took a year of French, but I had to take philosophy as well. Most of our engineering students go ahead and take a philosophy course. That's just my cut of the world. So. I hope that answers your question, Chris.
Yes, it does.
Okay. Leah, any questions?
I do.
Okay.
Could you tell me, where are some students, once they get their degree, where are they employed around here? I know you said Lockheed Martin. I know that's a huge employer for engineers. What about starting salary for Lockheed Martin or any other businesses that would be hiring engineers around here?
Well, where are you located?
Scranton.
Oh, you're in Scranton. Okay. The starting salary in Scranton, yes, Lockheed Martin up at Archbald. BAE Systems, which used to be part of the Lockheed Martin and IBM group that's in Binghamton. We have Morristown, New Jersey, Lockheed Martin. We have there's some Raytheon divisions in Binghamton, and let's see, obviously Boston, Massachusetts. Generally, Salaries run anywhere from 65 on up, depending on grades and experience. I use that tongue in cheek because I don't know what the exact salary was. I know that one of my students did an internship at General Motors 3 years ago. He said I had a summer internship at General Motors in the research lab up in Detroit area. At the end of the summer, they told him that he could expect an offer. And while he was in one of my classes in the senior year, he got an offer at $72,000 from them to start. I hate to make too much of a statement out of it, but generally starting salaries for engineers is pretty good, even in this area. Now, smaller companies will tend to go a little lower than that. When the numbers I gave you were some of the bigger companies doing some more sophisticated research. However, they're not going to be at the $25,000 and $30,000 and $40,000 range. That's just not what engineers. I don't know any engineers that have been offered anything like that. Most of them are in the high 50s, mid 60s, and above, depending again on grades and what the company needs, to be honest with you. Why do you ask, Leah?
I'm just curious. I keep hearing Lockheed Martin a lot. And we actually live close to Archibald, I should say. My husband grew up in Archibald, so we're familiar with Lockheed Martin and Archibald.
Mhm.
So I was just wondering, you know, I know, I'm just wondering what to expect salary wise coming out of school.
That's the kind of thing you would look at. And to be honest with you, I was the engineering director there before I left and went to Syracuse and was an engineering director up there, and then did some advanced work down in Morristown, New Jersey. Almost every engineer I hired was 65 and above, again, depending on grades and experience. And that's why I personally recommend getting internships. Smaller companies will be in the 50s. Mid 50s. But again, the more the student shows, that's why I really push for internships. Get out there and try. You have nothing to lose. So, but that's the kind of number that you're going to see. And I can't guarantee anything, and I'd be fooled to do that. But that's approximately what you would see. And I think that's pretty well standard. I mean, you're going to get a higher salary in a place called Syracuse in New York and Morristown, New Jersey, because of where they are. You're going to get a higher salary out of Huntsville because of where it is and what technologies there. You get a much higher salary in the Silicon Valley groups out in California. But generally, the higher the salary, the higher cost of living. That's one of those. That was the beauty of Archibald. You know, they have a good salary and a relatively reasonable cost of living.
Yep.
Yeah, and I still know most of the engineers out there, so or the engineering managers. So, anything else?
No, that's all. I think you've answered my questions. Thank you.
You're quite welcome. You're going to come out for a visit, Leah?
Yes, definitely. When do you have like face-to-face visits? When will that start?
That's a good question. My normal person from the admissions couldn't join me tonight, but I know we're setting up some face-to-face visits, and I did see one this past summer. They asked me to come in, and so go ahead and work with admissions, and I think we can set something up. And you're welcome to use my name, and in vain, I guess. But you go ahead. I'd be happy to come in. That's not a problem.
Wonderful. Thank you.
You're quite welcome. You're quite welcome.
I have a question.
Go ahead, Chris.
So if we were to take summer classes, like over the summer before we even go to Widener, is there a limit to Wilkes, the number of classes we can transfer in?
There is, but you shouldn't worry about it. It's like more, you have to have less than half of your major in half of the courses. So what I personally recommend, again, this is Bob Taylor's view of the world. I would say summer courses at some of the local community colleges in the so-called general education descriptors, the literature, the philosophy, maybe a social science, maybe something like that. Courses that do not require significant, technical detail that would be in your major. Now we do offer a lot of summer courses in our major. We've had a lot of folks like to do that, and we typically have done a few independent studies and some senior courses in the summer for students who wanted to get ahead. And if we can get a whole, I say a whole group, 4, 5, 6 students, it works out very nicely. You get good face-to-face connection with the instructor, plus you get some outstanding work. It's a little more concentrated though. We have 2 5-week sessions in the summer, so it's a lot of work, but you know what, you're focusing, so it's not so bad.
All right.
Okay.
Okay.
Well, I think they're going to tell me that I was way too long, but we waited to see who all could join us. I wanted to thank you for showing interest in Wilkes. If I personally can do anything for you, please feel free to get in touch with me. I'll give you my email if you want to write it down. It's Robert.Taylor with the number 1 after it. That's Robert.Taylor1 at wilkes.edu. Send me a note, tell me that we talked, and I'll answer whatever questions I can for you. And then do connect through with Jess or any of the folks in our admissions group. And I would be willing to come in if you want to come in and take a look at some of our labs. Obviously, in the present environment, we're doing masks and social distancing and all that kind of thing. But I know that I have seen some of the tours, and I have come in at a special request. So happy to do that for you. Okay.
Thank you.
Thank you. I really appreciate your interest in Wilkes, and hope to see you on campus.
Thank you.
Thank you.
You're quite welcome. Thank you. So long.
Bye.
Mhm.